Good morning, children. Today we'll discuss about chemical changes and reactions. Second chapter, chemical reactions. Chemical reactions is just the process of breaking of the chemical bonds of the reacting species and making some new bonds. So bond break for the case of that reacting substance, that is the reactant, and the new bonds are formed to produce products. And the definitions of chemical bond: this is the force that holds the atoms of molecules together in a compound. It is the chemical definitions of chemical bond. A chemical change or chemical reactions occur when particles collide. And for successful chemical reactions, there should be an effective collision. Collisions occur when the reactants are in close contact or by supply of energy. So for successful chemical reactions, effective collisions should be there. Few conditions are required for these chemical changes. First is the mixing, that means the close contact. This is only for effective collisions. For example, when iodine and phosphorus react explosively, they are brought in close contact. Lead nitrate react with potassium iodide to form lead iodide and potassium nitrate. This is the lead iodide, which is yellow in color, and potassium nitrate is formed. In some cases, chemical reactions occur when substances are mixed either in molten or in aqueous state. For example, common example for the precipitation reactions: when aqueous solutions of sodium chloride react with aqueous solutions of silver nitrate, a white precipitate of silver chloride formed, but there will be no reaction if we mix sodium chloride and silver nitrate solids in solid state. The next is the heat. Some chemical reactions occur on heating. For example, decompositions of copper carbonate. Copper carbonate decomposes on heating. On heating, copper carbonate decomposes to produce copper oxide and carbon dioxide is formed. Lead nitrate decomposes on heating. So in this case, this symbol represents the heat. Heating is required. Next is the light. Next conditions. Some chemical reactions take place by the actions of light. These are called photochemical reactions or photolysis. Plants, this is for the case of photosynthesis. This happens only in presence of light. You can write H nu. This is a symbol of light, H nu. This is a symbol of heat. This is a symbol of light. Hydrogen and chlorine react in presence of sunlight to produce HCl. Chlorine water decomposes in presence of UV radiations or in presence of sunlight. So you have observed that few conditions are necessary for the successful chemical reaction. First is the main points is the effective collision to produce a new chemical substances. Next step is the electricity. Next conditions. Certain chemical reactions, mainly the electrolysis, occur only in presence of electricity. For example, electrolysis of acid diluted water occurs only in presence of electricity. To give hydrogen and oxygen is the electricity. On passing current, sodium chloride produce sodium and chlorine. Sometimes pressures are required for successful chemical reactions, and this pressure brings the reactant closer so that there should be an effective collision. Now mercury chloride and potassium iodide, when rubbed, they will give mercuric iodide. Nitrogen and hydrogen produce ammonia gas only in presence of pressure in the Haber process. Sometimes catalysts are required for successful chemical reactions. Catalysts, these are the substances which affect the rate of chemical reaction. Catalysts may accelerate or decelerate the rate at which they occur. If they increase the rate of reaction, they will be termed as positive catalyst, and if they decrease the rate of chemical reaction, then it will be termed as negative catalyst. For example, when potassium chlorate decomposes only at 700 degrees centigrade, but in presence of manganese dioxide, lower temperature is required. So temperature initially without manganese dioxide 700 degrees centigrade, with manganese dioxide 300 degrees centigrade. That means manganese dioxide will increase the rate of chemical reaction, and that's manganese dioxide is just the catalyst. Ammonia reacts with oxygen to produce nitric oxide in presence of platinum as a catalyst. These reactions is very important reactions. Platinum as a catalyst. Now, as we have discussed about that, when the catalyst accelerate or increase the rate of chemical reaction, they will be termed as positive catalyst. For example, rate of decomposition of hydrogen peroxide increases in presence of manganese dioxide. It is a positive catalyst here. Sometimes promoters are used. Promoters, the substances that influence the rate of chemical reactions by improving the efficiency of the catalyst, are called promoters. Promoters have some direct influence on catalyst, not on the substances. They have some direct influences on catalyst. In the manufactures of ammonia, iron acts as a catalyst. Here iron, it will act as a catalyst, but molybdenum act as a promoter. This molybdenum increase the efficiency of iron to produce ammonia gas. Negative catalyst, they will decrease the rate of chemical reaction. Phosphoric acid reduces the rate of decomposition of hydrogen peroxide. Now, most important examples is the chloroform. The rate of oxidation of chloroform decreases in presence of alcohol. Now listen, this chloroform on aerial oxidation produce phosgene gas, and this phosgene gas is very harmful for human beings. To avoid any formations of phosgene gas, alcohol, any sorts of alcohol, basically ethanol, are used or mixed in the chloroform bottle. So this alcohol decrease the rate of aerial oxidations or any sorts of oxidations for the case of that chloroform. Then an interesting observation is that sometimes sound energy is required for a successful chemical reaction. Certain chemical reactions proceed by absorptions of sound energy. And for example, acetylene breaks up into carbon and hydrogen by absorbing sound energy. C2H2 is the formula of acetylene. On absorbing sound energy, they will produce carbon and hydrogen gas is evolved. So we have learned that these are the factors or conditions necessary for chemical reactions. Now we'll understand the characteristics of chemical reactions. First, evolutions of gas. In many chemical reactions, sometimes products are the gas. For example, when zinc, granulated zinc, when react with dilute sulfuric acid, or you can use dilute hydrochloric acid also, hydrogen gas evolved. And this gas evolved, if it is with the sound, then it will be termed as effervescence. This term. This is the evolutions of gas with sound from the solution mixture. ZnSO4, since it's soluble in water, it will remain in the water. This will be in the aquated state. It will be in water state, aqueous solution. Now, as we have learned that the formations of gas bubbles in a liquid during the chemical reactions with sound is known as effervescence. This is the definition. Sometimes color changes during the chemical reaction. For example, when a few pieces of iron is dropped in a blue colored copper sulfate solution, the total solutions become green, and copper deposited on the surface of that iron nail. This copper deposited as the red depositions, it will remain in the solid state. Copper remain in the solid state, while FeSO4 will be in aqueous solution, AQ, for the aqueous solution because it is soluble in water. You have to give iron as a solid state. The silvery white blue color solutions changes to the green color solution due to the formations of ferrous sulfate solution, dirty green solutions. Now iron is more reactive than copper, so iron displaces copper from copper sulfate solution. Iron displaces this copper from copper sulfate solution. These type of reactions is known as displacement reactions, and this is due to the more activity of iron than copper. Next characteristics is the formations of precipitate. Class 8, you have observed that precipitate means that insoluble solid substances are called precipitate. Insoluble solid substances are called precipitate. For example, when a solutions of silver nitrate is added to the solutions of sodium chloride, aquated, AQ means aquated, this is for the case of the aqueous solutions, aquated clear solution, and this is the precipitate. Sometimes down-headed arrow are used to indicate the formations of any precipitate. NaNO3 remains in the water solution. When ferrous sulfate solution is added to the sodium hydroxide solution, a dirty green precipitate of ferrous hydroxide is formed. This is the formations of ferrous hydroxide, and this down-headed arrow is represented only for formations of precipitate. The last characteristics is the change of state. In many chemical reactions, a change of state is observed. For example, when ammonia react with HCl, these are in the gaseous state. G stands for gas. They will produce ammonium chloride, solid substance. S stands for solid. This is the reversible symbol, reversible sign. This reaction is reversible in nature. Ammonium chloride may decompose to produce ammonia and HCl back. So in this case, the state change from the gaseous to the solid state.